So here we go again. Once again, we've got our function g on the top. We've got g prime on the bottom. Let's do this. So we see here at -3, our tangent line has a slope of 2. So that's our y value down below. And now we notice that the graph of g is going to be straight all the way from -3 to -1. So that tells us that all of our tangent lines at all of these points are going to have the same slope. They all have slope 2. Slope of 2, slope of 2, slope of 2, which means all of these points down here are going to have the same y value, 2. So even though this point of tangency is moving, the slopes never change. And so that's why this value of g prime doesn't change. What happens when we reach the point right here? That's a corner. And we know that at corners, there is no tangent line. So if you're going to zoom into this point, you'd see that the graph wouldn't look like a line no matter how far you zoomed in. So that means that the derivative at this point does not exist. And so down below, that's why we have these open circles. So it signifies that g prime at -1 does not exist. Now when we pass -1, now we get our tangent line back, but it's suddenly negative slope. So g prime is now down here. It's negative. As we go forwards, well, we're still going to have negative slope, but the slope is less negative. It's less negative here, and finally at 1, it's now horizontal, a slope of 0. And that's what we're seeing in g prime as well. We start with very negative, less negative, finally 0, corresponding to the horizontal tangent line. What happens when we move beyond 1? Well, at all of these points, 1, 2, 3, we're still going to have horizontal tangent lines. So these are all horizontal. They all have slope 0. And so that's why g prime is just 0, 0, 0, 0, 0 all along here. And that is the story of our derivative.